Thank you all for the nice introduction. Yeah. So now we want to give a quick update. Yeah, what we are doing at Mercedes-Benz. Yeah, from a manufacturing perspective. Yeah, in regards to machine learning, and then at the end, yeah, Philip will give a deeper dive what we are doing with computer vision in detail. Yeah. So in general, I would say we are quite new to this business. I'm honest. Yeah. We started our journey maybe 2.5, 3 years ago. Yeah. And we want to just quickly show what we have achieved, yeah, with computer vision, yeah, and go from there. Yeah. So first of all, a quick introduction from ourselves. So my name is Oliver. Yeah. As you can maybe hear, I'm originally from Germany. Yeah. I work for Mercedes since 22 years. Yeah. It's quite long. My background is numerical simulation, so I'm kind of a simulation guy, but AI is something completely new also for me. Yeah. I worked in different places here in Germany, in China, where we have a huge production site, and in the United States, I think since 6 years, yeah, where we have our production location in Alabama. And yeah, quick Philip. Yeah.
Yes, thank you. So I'm Philip Tecklenburg. I work for Mercedes now for 9 years. Most of the time by now really here in the US, so that's interesting to me too. I studied electrical engineering, and I'm working as an engineer on AI vision besides problem solving on our manufacturing sites at that point. Yeah.
Good. Then I read an article 4 weeks ago, yeah, and I found this statement quite interesting, yeah, because at the end, and this is what we figured out in the last 3 years, it is not so easy, yeah, for guys like us, yeah, to implement AI and computer vision and into the day-to-day operation of a plant, yeah, where our main focus is producing cars, yeah, and not, and we are not experts in AI, yeah, just to say it easy. But nevertheless, yeah, we have a lot of data, yeah, and this data gives a lot of opportunities. So when we start producing or developing a new car, yeah, we have a lot of data in the digital twin, what we call. Yeah, we have all the information from a car in CAD. Yeah, when this is set up, yeah, we source these parts. Yeah, then it goes to the logistics and supply chains. Yeah, where we try to track these parts. Yeah, and then it goes into manufacturing, yeah, where we then produce the car in different shops, body shop, paint shop, assembly shop, and also there we collect thousands of data, yeah. So we know exactly which weld spot fails, yeah, based on current, yeah. For a lot of weld technologies, like for example MIG, this is not possible. There comes AI vision into place. Computer vision helps us there a lot. We will bring this as an example, yeah. And then when the car is at the customer, yeah, we collect telematics data, we collect data from the customer where the customer can give us feedback via the Mercedes Me app. The car had this malfunction and ask for his help. What is incredibly challenging, yeah, is connecting all this information. Yeah. This is the final goal, I think, yeah, where we want to get at the end faster. Yeah. And this is maybe where machine learning in a couple of years, because we are not yet so far, will help us, yeah, to make the development phase faster, the manufacturing fast, maybe more quality reliable, yeah, and the customer feedback, where we then solve the failure resolution from a customer which has an issue, that we can track the complete car down the complete line and then see, okay, this could have caused an issue. Yeah. This is the big idea. We have running projects there with multiple companies. Yeah. Also, a US company is helping us there out. One big company in Munich. Yeah. This is the big picture, yeah, from what we see. Then when we go to the next page, yeah. So what makes it additionally challenging, yeah, is that we have different production locations. So we have a huge production network. So we produce cars in Europe, yeah. We produce cars in the US, yeah, and cars in China. And these different countries have totally different regulations, yeah, when it comes to machine learning. Yeah. So for example, when I start in Europe, yeah, where our headquarters is, yeah, Europe has a high data protection standards, yeah, so it's not so easy to share data under each other. We have a very strong labor force, which makes it difficult to install just a camera in the plant. As soon as there is a head on it, a real person visible, then this will never work. And the issue is also that we define our standards in Europe. So even if we are quite successful with what we do in the US in regards to computer vision, so far it was not possible for us to transfer this to Europe, because we get there a lot of backwinds from our own company. In general, US has an AI ecosystem. I think this is why you are all here. There's a huge amount of technology openness. A thing like Waymo, I'm not sure if this would be allowed in Europe or doable in Europe. And we have a workforce agility which is way higher. So something like me working 22 years for one company is quite unusual, I would say, in the US. And then when it comes to China, when we try to roll out something like computer vision in China in our plants, then often we get the statement, no US-based AI is allowed there. We even had to develop for a new car which we just launched. We don't call it, we call it self-driving assistant. We call it not autonomous driving. We had to develop our own new software with a Chinese company. The thing which we develop here in the with NVIDIA, we had to develop a second time with a Chinese company just to be able to launch the car there. So there's a huge impact there. It's sometimes not so easy. Even if you have found a solution in one continent, it doesn't matter you have found a solution in the other as well. So this was maybe a little bit the bigger picture. So where are we coming from? So our plant is located in Alabama, deep south of the United States. The plant looks like this. We have a huge body shop, paint shop, and then from there the cars goes into an assembly shop 1 and assembly shop 2. Roughly 6,000 direct employees. We built there 7 models, and our volume is roughly 250,000 per year. Just that you know where we are coming from. Then you can see our cars. These are the cars we produce. The big SUVs, the GLE and the GLS. These are the 2 combustion engine on top, and then the 2 electrical cars, the EQE and the EQS. So before I hand over to Philip, because today is also kind of a special day for us, because exactly 140 years ago, the patent for the first, what we call now a car, was achieved by Mr. Benz. And since then, I think we stand, and I quickly want to show this video, we stand kind of for innovation and for quality. This is why computer vision is a huge possibility for us. Okay, exactly. That's something like this. Does not happen again, yeah. We can use computer vision to make our manufacturing process better, and this is now what Philip will talk about.
Yes, the innovation we saw already in the video. Mercedes was a driver, is a driver of innovation right now. The complete markets are changing as well. We have a lot of new competition, I mean, for quite some time already from Tesla, what we saw before, from Chinese markets. In this presentation, we will focus a bit on our activities as well. This is just scratching the surface on the activities Mercedes-wide. This is just the things we are allowed to share at this point. But in production and manufacturing, we are separated into 3 shops, as Oliver mentioned before already, which have very different requirements. The body shop, for example, is like the paint shop, highly automated. 98% of our processes are automated. So we have robots manufacturing our cars, building everything. We have people who need to work with the machines and need to be able to train them to work with them. In body shop, we have the high need of integrity of joining technologies. So whenever we have a crash test, we need to make sure that the customer is protected at that point through high reliability. In paint shop, we have surface quality. We see scratches and dents, as Reza referred to before already from other systems, but also water tightness. So we need to make sure that if we have a PVC seam on our contours, that they are tight as well. In assembly shop, we have a very low automation. Why do we have a low automation currently? For sure, we can go with robots at some point, hopefully, but currently we are not there yet, and we need to have a low automation to bring in the variation as well. So we have a high individualization with huge amounts of variance. It's way more than 10,000. Just if we think about the combination of different colors, different body types, different now I'm missing the word, models at that point. We need to have a good build integrity. Also, torque values need to be fulfilled. So there is data which is being generated as well. And in EE commissioning, we have to make sure that all the connections are made, so all the functions are done at that point. Otherwise, problem solving in the car industry or in the car can be very challenging. How do we currently check this? We have 4 different layers of quality management, of quality checks. First is always the self-check. Self-check, a team member puts on a part on a vehicle. Hopefully we can have a poker yoke. Poker yoke means there is only one way to assemble the parts, so they cannot assemble it the wrong way. If we have a machine, like in body shop in many areas already, we have adaptive weld control. The adaptive weld control gives us already 10 signals per second from the shop. So this is data we are processing already, we are working with. If we talk about the DC tools, this is the torque values we are using in assembly shop. We have 800 DC connections per car. So this is a lot of data we have, and based on the data, we need to go into problem solving to make sure how can we resolve this. Next step, the next layer is a quality gate. So I have the car going down the line, and there are specific quality members who check visually different contents and make sure that we are fulfilling our requirements. These checks is where we see a high potential for computer vision, because humans who are checking have an accuracy of around 70 to 90%. Depends on how many colors they have to validate and content what they need to validate. Yeah, that's why we go with computer vision, to get more consistency. Then we have sample checks, which is visual inspection of the complete vehicle and also weight tests, for example. And we have a lot of measurement data. So we get 250,000 measurement characteristics per week of a car, just on the sample size, just to make sure that our dimensions are fulfilled. And then the field feedback, what we saw before already, is where we have the customer experience. For sure, if they go to the dealership and complain about it, we need to find a way to document it, but also the general market data. So from the GLE and GLS we saw before, there are around 1.5 million cars in the market which constantly provide data at that point as well. So this is data which needs to be analyzed. We want to focus on the computer vision because that's where we see a huge potential, also with the focus on reduction of redundancy. So content which is being checked already in QLoop 2 does not need to be checked in QLoop 3 again at that point. What obstacles do we have? We have a brownfield. So our construction, the implementation of computer vision in a running system requires several different steps. As a first step, we need to install a camera. Camera install is already in a layout where we have production is running. We need to find a way, how can we implement it, how can we have the right lighting. Mercedes has a lot of standards, especially as a German company, we like standards. So we get from Europe already very clear statements on what kind of hardware we can implement and how can we work with this hardware. If we want to have exceptions from that, that brings it already very challenging at that point. We had, for example, interaction with other or with computer vision companies. They wanted to provide their own hardware, which would have required us to set up the whole power and everything around it as well. For a trial of 1 month, they wanted to charge us 30,000, which was kind of, before knowing how good their technology is a big hurdle for us to actually implement it at that point. The next step is the data processing. We saw previously already that a lot goes through the cloud. If we are in a production system and we have a running line, the cloud cannot be our only dependency at that point. If we have any struggles, we prefer having actually GPUs on site, but the implementation of GPUs in our data centers is also not that easy. So this is something where we need to have flexibility at that point on which GPUs to use. As a next step from the hardware side, we need to include as well product information. And product information goes in the direction from the PLC. So we have a lot of automation cells already in place, and the communication structure is very clear. So we need to make sure that we can have interfaces at that point, which brings us as well, after the brownfields of the hardware, to the multiple interfaces we actually see in the IT infrastructure. Left side is where we see already the edge device with the camera, and then it goes to the AI vision. We need to include the product information. So we need to know what kind of car are we actually checking. We need to store the images. We need to be have the availability of the stored images to process them as well again. We need to have a visualization so we can visually give feedback to the team members in line. Whenever they find a fault, they know how to react and how to rework it. We need to make sure that the system actually runs. So this is all existing systems, and we need to find a way on how can we process the data at that point. It's not affecting the development of the AI, but it's always affecting how can we actually implement the system and work with the system at that point. Because only if the change management and the implementation of that system actually takes place, it's going to be a long-term success to implement and be a long-term customer at that point. This right now is an example of a MIG weld. A MIG weld is being put on in body shop already. It's very crash relevant. We installed a camera to evaluate before and after rework. What does the process look like right now? So there is a body is coming into the station. A team member stands there, takes a look at the seam, and welds it if it looks bad. Every team member is different. Sometimes they rework more, sometimes they rework less. But with this, we have transparency actually of the data and see which seams often need to have rework, so complete new generation of data. And as well, is the rework done correctly as well? So it's a good confirmation for us to work with the data and have transparency. The next part is an underbody fastener use case. We have on the underbody of the cars, we have panels. They are attached with fasteners. If one of these fastener loses, we have NVH topics. Noise, vibration, harshness, so sound issue. You always hear a rattling noise if something is missing. This is right now, if we want to have a buy-off process at that point, we have here an image where we see these are missing bolts. We need to have reliability in the system. So our production team, our quality management team needs to know exactly that it's not stopping line when it's not supposed to, and it's only finding the right issues at that point. We have 4 different types of bolts, all have the same label at this point, and we have 85 to 100 bolts in each car. So if we want to have a buy-off process, at Mercedes we have a special process which is called a measurement system analysis. And this is testing, this needs to check that each bolt is being detected correctly, because we want to replace a human who's checking it. And for a human it's quite easy to actually go that way. So 85 to 100 different bolts we have on the car, and we need to find out which location is the bolt actually missing, how accurate is our training, how reliable is the system at that point. And yeah, therefore we see challenges, or we have challenges getting the complex use case actually broken down to make it useful in our production. Sorry, I need to drink a sip of water.
Okay, also this buy-off process is for us a challenge. Yeah? This is not so easy. Yeah? The guys accept more from an AI vision system than from a human being, to be honest. Because at some point it gets measurable, and if you have only 5 slip-throughs, yeah, then they start, or they will most likely not accept the system. Yeah? This makes it difficult. Another use case which we have implemented is, for example, the VIN label. Yeah? So this is quite useful. What can happen there is, on each car, yeah, you have to implement or put a sticker on it, and this VIN label describes the car in detail. So this is a governmental requirement. So each time we have a wrong label on a car, yeah, we need to remove it. This can be quite cost intensive. Yeah? And create downtime in the line. Yeah. So.
Sorry, thanks. So false positive causes for us downtime. What's the cost of downtime? If a production line stops, in our case, 1 second is around 600 to 800 US dollars. So getting a business case out of it, the implementation of an AI vision system, and we have a lot of false positives, that's going to drive this down as well. If we have false negatives and we miss the right detection at that point, we have expensive rework. Right after this station, the windshield is being installed. So whenever we have a wrong label on there, we need to cut out the windshield, which is very time intensive. If there is a slip through and it's not recognized before it goes into the market, they cannot register, the customer cannot register the vehicle. So they will be very mad at that point too. So this is something we need to catch, and we need to have the reliability of the system at that point. Brings us to the main key takeaways. So machine learning for us is a tool like a super high-tech screwdriver, but for us, we need to have it usable at that point. The integration needs to happen within a hardware and an IT brownfield. Means the infrastructure is not easy, and for us it's challenging on our side, but we need to have flexibility on the systems which are actually being provided. The international production network makes it more difficult for us to scale among all other production facilities at that point. And the trust in the system is most important to actually drive the change management, because change management, especially in our industry, is really important these days. There is a lot of things going on, and therefore, yeah, we need to get reliable systems in place. Good. And one of the last topics as well, so if we're working to replace team members checking the vehicle with the visual inspections, that's one step, but there still needs to be someone who's actually running the system. So it's at that point not only a substitution of the team members, it's also an adaptation and a collaboration with the human at that point. So that's what we need to have at that point. Good. Thank you very much.